Welcome to the workshop. Today we want to take a look at the ratio test. So let's use the ratio test to determine if these two sequences converge or diverge. For the first sequence, we're looking at 6 to the n over n plus 1 cubed. And the ratio test asks us to take the ratio of a sub n plus 1 divided by a sub n and determine if the limit of that ratio goes to a number that's less than 1 or a number that's larger than 1. So we need the absolute values of the a sub n. So in general, the absolute value of each of these terms will look exactly like it is as given because they're all positive. Nothing different. So then if we were to take the limit as n goes to infinity, now if we're taking and dividing by a fraction, we can multiply by its reciprocal. So I'm going to take a sub n plus 1, which is 6 to the n plus 1, divided by n plus 1 plus 1, so n plus 2 cubed, and I'm going to multiply that by the reciprocal of a sub n. So that would be n plus 1 cubed divided by 6 to the n. Now, of course, this is equal to the limit as n goes to infinity of 6 to the n and 6 to the n plus 1 reduce. So we just have 6 n plus 1 cubed divided by n plus 2 cubed as well. Excellent. With this is just a ratio of polynomials. So we can see that it should be, since they're even, or since they're the same degree, it's just the ratio of the leading coefficients. So that's just 6, which is greater than 1. Thus, by the ratio test, the series diverges. Again, we're taking the limit of the ratio of the terms, a term and a term that precedes it. And when we do that, term divided by term that precedes it, and if we get a number that is larger than 1, that means the series diverges. If we get a number that's less than 1, then the series converges. And if it's equal to 1, then the test is inconclusive. In the case of convergence, we actually have that it is also absolute convergence. Excellent. Now, in this case, when we look at the absolute value, it's just removing this negative 1. So this is 2 to the 4n divided by 2n plus 1 factorial. So then we take the limit as n goes to infinity of the n plus 1th term. So this is 2 to the 4 times n plus 1 divided by 2 times n plus 1 plus 1 factorial. And then instead of dividing by the nth term, we're going to multiply by the reciprocal. So that's 2n plus 1 factorial divided by 2 to the 4n. This, of course, we can reduce. So this is equal to the limit as n goes to infinity. 2 to the 4n plus 1 divided by 2 to the 4n will leave us with 2 to the 4, which is 16. And then this is 2n plus 3 factorial. So we have a factor of 2n plus 3 and a factor of 2n plus 2. And then the 2n plus 1 factorial cancels out. And this limit is equal to 0. So here we have that the series that we're interested in converges, and it converges absolutely. Thus, by the ratio test, the series converges Absolutely. Excellent. So we'll also take a look at the root test, and then we'll take another look at deciding which test to use given a series. So we'll see those shortly back here in the workshop.